Welcome back. Today we're going to look in more detail at how parameters are passed to functions. So the function call is the statement which actually invokes the function. And here in this program, you can see here in main, we have the actual function calls located right here. And so these statements invoke the functions which are declared up in our function prototypes here and are defined down below. And when a function is called, the control is actually passed to that function. So let's try that out. So what I'm going to do is I'm going to run this in debug mode. And to do that, I'm going to put a stop point right here at line 19. And then there's some shortcut keys to do this. So we're going to start debugging with F5. And so often when I want to memorize my shortcut keys, I'll look up the menu, find the shortcut key, click off of it, and then I'll hit the shortcut key. So I'll hit F5 to run in debug mode. And we can see the program was started, execution halted at write hello, and we're sitting at write hello. Let me arrange this so that it's a little bit more concise. And so we're now sitting here at this function called write hello. In debug mode, in order to step into a function, what you need to do is instead of using step over, which is F10, we're going to use step into, which is F11. And what F11 will do is it'll actually execute that or step into that function. So I'm going to hit F11, and you can see we went from this line of code where we invoked the function to inside the actual function itself. This yellow pointer is the instruction pointer, so control was actually passed by the processor to this function. We're now going to F10 through each line of this function, and we can see the cout is executed. We're now sitting at the end of this function, and watch what happens when we continue on. I'm going to hit F10 one more time, and we can see now control returned back to where that function call originally occurred and then went on to the next line. So now again, we're sitting in front of a function call, ask for name. And so I'm going to, again, hit F11 to step into that function. We hit F11 and we can see now we're inside this ask for name function. I'm going to F10 to step through each one of these, and we can see it executes the lines of code. Name is initialized to nothing. A cout is executed to tell the user that what you want is their name. And then we execute the get line. So I'm going to put in a name. And we can see now name has the value Rob. We'll now step over one more step for the return. The return gets us to the end of the function. And when we come back, we can see that we're now back at the function call. Now there's when you look at this, realize that the function call is really one statement and the assignment operator is a second statement. And so now we're sitting here with the return value for ask for name as Rob. And now we're about to do this assignment operator. We can see that name is currently empty. I'm going to hit F10 one more time. And we can see now that name has taken on the value that was returned by the function because of this assignment operation. That's very important. If your function returns a value, you need to do something with it, and typically you're assigning it into a variable. I'm going to do this again, and we'll step into the next function. It goes to that function. We're going to execute those commands. It's going to ask age. Let's put something likely. And then we can see we're at the cn.ignore part. And the reason for the cin.ignore is because when we do a cin, it leaves the carriage return in the return buffer. So after your cins in a function, you always want to do a cin.ignore before you return. I'm going to hit F10. Age is what we're returning. We go back to the main function, back to where the function call originally branched into that function. And then we do the assignment operation, which changes age. And now we can do the write function. Again, I'm going to hit F11 to step into that function and see where it goes. Sometimes you'll have this happen. You'll step into a function. If there's a string involved, it sometimes goes to the string library. If that occurs, no big deal. Just go to your debug and you'll find that there's a step out function, which is Shift F11. So that's what I'm going to do now. I'm going to hit Shift and F11. And then hit F11 again to actually go into the function. So now we're in this function again. I'll step through it. It'll do the output. And then we'll continue on. And so that's how you can see the function calls. I'm going to stop debugging, which is Shift F5. So rather than hitting that, I'll hit a Shift F5. This stops debugging. Coming back to our presentation. So when the function was called, you saw how the control was passed to the next function. And when the function is complete, return is returned back to where that function call occurs. And so the other thing that you might notice is that when we called it, we passed two variables in, name and age. And in this instance, they happen to be the same name as this function here, which has name and age. In point of fact, they don't have to be the same. And so we could actually rename this age function And so what I've done is I've renamed the name and the string in main. And notice now we just have some text and we just have a number. And you can see it changed it throughout. By the way, that's Control-R control function is probably the best way to rename a variable because it'll make sure it renames everywhere where it needs to be in scope. But notice in our actual function down here, it's still name and age. So the parameter name here does not have to be the same as the argument name that you're passing in. And it will work just fine. I'm going to run this with Control F5, which is without debugging. And you can see these parameter names are independent of the names provided in the function call. So, and you know, that kind of makes sense. Let's say we wanted to call this function and we wanted to call it by passing in just some literal values. Well, we couldn't require these to be variable names that match the function because otherwise this form of the function call would not work. And if I run that, you can see that both function calls worked. One was called just by passing some literal values. The other one was called by passing in a variable name. And this function will work with anything that you pass in here as long as the first thing is a string and the second thing is a number. So with your function definition, it's less important to have the variable names here than it is. It's not necessary that these variable names align with the names that are passed in as arguments when you call the function. So those are the function calls. We ran through all of those. Or, well, these are function calls for the hotel program. And you can see that's kind of the same thing. And we can run through those and kind of see how that works. So here we have some declarations that occur. And over on the left, we're just going to have some boxes that represent what's being stored in the data of the program. And when we do these function calls, note what happens here. When we make the call to how many people, the variables that are in main are actually now out of scope. This function can't see the variables declared in main. All it can see are the parameters passed in and the variables declared inside the function. So in this case, num is the variable declared in this function. And so when we execute the code in here, and we get, we ask the person how many people there are, and we get the number, and we assign that into num, we get that value stored in here, and it gets stored in the variable in memory. Now, when we return, that variable the variable num actually goes out of scope, and it takes this assignment operation to take that variable that came out of how many people and store it in a variable. In this case, it's num people. Going to the next function call, which is how many nights. Again, this will all go out of scope. This function can't see the variables declared in main. And in addition, you can see that it's declaring a variable called num that just happens to be the same name as what's in how many people. However, this variable num in how many nights is not the same variable as variable num in how many people. This is a different space in memory. And so the way you can think about this is every function has its own space in memory to store its variables, and no function can see the ones in the other one. And so we go through, we get a value from the user, they put in 3, we return that number back to main. And again, all these the variables that are declared in this function are no longer visible to main. And in order to save the value, you have to have this assignment operation that stores it in a variable here. And that's how main can retain the results of these functions. So let's look at some different formats of function calls. If you're calling a function that has, say, no inputs and no return value, notice that the function doesn't have an assignment operation. That's because write greeting is void. There's no reason to do an assignment. It doesn't actually return anything. In this case, if we have functions that return values, we need assignment statements in order to preserve what they return. Otherwise, what they return just goes away. So you need those assignment operations. And if you have a function that has input values, it'll look like this. You call write, you're calling this function and you're passing values in. But again, because this function is void, it doesn't return anything, and there's no assignment operation. And then you can have functions that do everything. And often these are calculate functions where you're passing in values, it's doing some computations, and then the results of those you assign into a variable which you're going to use later on. With programs, we say that we are calling by value, and all the functions we have so far, when you pass a parameter into a function, it's actually copying the values over into the other variable. And so we can look at this with this example where we change the names to just a number and just some text, and then we have the function call over here. When we make this function call, we're not actually passing the variable just some text over to this variable name. Instead, what's happening is the value that's of just some text is being copied over to just some name. So I'm going to set my instruction pointer here, or a stop point here, and I'm going to call these functions, and I'll run in debug mode. And we can, let me shorten this up a little bit. Okay. And let's see, we'll get through the first part of this program. And now we're sitting here at just before this function call. So I'm going to notice that right now, just some text has a value Rob, just a number has 1000, and we're going to pass it into this write function that's defined down here. And so I'm going to step into this function with F11, and unfortunately we ended up in the string library, so I'm going to jump back out with Shift F11, then F11 again to step into it. And now we can see that, notice that now name and age have those values. So what happened is the values that was in just some text and just a number were actually copied into these variables. And also notice that if right now, if I hover over just some text and just a number, I don't see their value. That's because they're not in scope. Down here in your debug window, that shows the variables that are in scope. And these are the variables that are in scope at this point where the instruction pointer is. And that's just the age and name value parameters. When I step through here and it does its output, then it can display those values. So realize what happened between the parameter, the argument that were input into the function, and the actual function is the values were just copied. So, call by value. Does it copy the variable into the input parameter variables of the called function when when data is passed to the function? Does it copy a pointer to the variable? Or does it copy the value of the variables into the input? So is it the actual variable that's being passed over, or is it some kind of pointer thing that's being passed over, or is it just copy the values of the arguments to the parameters, or none of the above? So pause, think about the answer, and then hit continue. The answer is that it copies the values. So the answer would be C. So let's try this. Let's write the prototype of a function called multiple chars that returns a string and takes two parameters, a char called char2repeat and an int called numchars. So we're just going to write the function prototype. So pause, try to write that down, and then hit continue. Okay, so I'm just going to use this program to do the function prototype up here. And let's see what that looks like. So it would look something like this. It's going to be called multiple chars, so I could put that down. But for our function, we need a return type, and we can see the return type is string. And then all functions need parentheses, so that's my parentheses. And what types of parameters does it pass? Well, it needs a char called char2repeat. And it needs an int called numchars. So that's my function prototype. So now let's look at how variable names are used in functions. So variables have ownership of variables. So let's say we have, let's look at the sum 1 to n program. And this program, it has a main function. It has two other functions, a get number and add 1 to n function. Notice the function prototypes are defined above and the actual function definitions are below. Notice that we declare two variables inside of main, and we call that get number, the get number function, and store it in X, call the add to 1 to n function, and put it in sum. And then it shows the results. So get number is just a get function. Notice it has a void parameters and a return type. So it's just asking the user to enter a number. And here you probably should have a cn.ignore as a matter of principle, just in case you ever add a get line later on. And then we have our add 1 to n function. And it takes a parameter n, and what it does is it It initializes a total variable equal to 0 and an I. This can be kind of confusing. It's legal to have multiple declarations. We're declaring two variables, total and I. This is really the same thing as this. And then we're looping through from 1 to whatever variable came in, and we're just adding those variables up. This is called accumulation, where we're taking the value that we're at and adding it to the current total. And this will just keep updating total until it gets the total. And so if we run this, the program looks like this. So the results from adding 1 to 10 is 55. And that's what is output here. So when we call that function, add 1 to n, we pass in the number we got from the user, and then we do some work and get the sum. So let's look at this from a variable ownership perspective. This function, getNumber, the only things it sees are the variables declared in it and the parameters passed in. Since no variables are passed in, or nothing's passed in as a parameter, the only variable it sees is number. In add to n, we have a parameter n, so it sees n and total and I, which are declared inside the function, but it doesn't see anything else. And in main, it sees x and sum, but it doesn't see any of the variables declared inside of the function. And we're passing in x. This variable does not have to be the same as the parameter. So the parameter is n, but we can pass any variable we want to this function as long as it's an integer. So we're passing in x. So we say that the variables are local to the function where they're defined. In your book, it's kind of illustrated like this. And the way that looks is this. So let's say here's our functions, and we're going to start off with the instruction pointer in main. We declare some variables, and these variables are now visible inside of main. We now are at the function call. When we step into that function, number gets declared. The variables inside that were declared in main are not visible inside this function. Only the ones declared inside this function are visible there. As we step through and execute our code, when we return, notice that what happened is that the value that was in number is assigned to a variable in main using this assignment operation that we wrote. If we don't provide that assignment operation, we'll lose the value. Next, we go to the next function call, and then when we go to that next function, the variables in main go out of scope. The only ones that are visible are the ones declared inside of this function now. And so this function just lives within its own little memory space. It does its work, and as it's going through and doing the total, notice that it keeps adding I to total. So 10 plus 4 will be 4. Well, I guess we get 15. Then we add next value, and it just goes through and keeps adding all the values up. Eventually, when it returns the sum, the value that gets returned from add 1 to n gets placed in the sum. And once you come back to main, notice that the variables that are in main are the only ones that are visible. So we have the 8 and the 36. So when we get to this next output, we have the value 8 is there for x. The value for sum is 36, so that's what gets output. So there's some common problems with functions we'll look at. One common one is an undeclared identifier error that you might see. So let's say, and it'll look like this: error C2065 age undeclared identifier. It's tempting to just say I've got an error and start trying to troubleshoot right away, but you should really try to read the error messages and see and use those as a hint for what's wrong. And here we have age and name are not declared, and here's the code that caused that error. So here we have name and age, And then here inside of ask for age, notice we have our ask for age function that's being called here. And we're trying to cin into a variable called age. But it was never declared inside of here. Sure, a variable called age was declared in main, but that's in main's memory space. It's in main scope. Within the scope for ask for age, there is no variable called age. And so you will get an error because the computer says, well, there's nothing in scope called age, so I can't process that code. And that's where you'll get these undeclared identifiers errors. Same thing for ask for name. Notice we're trying to input into a variable called name, but there is no name declared inside of ask for age. There's only one declared in main. So even if variables have the same names in different functions, the functions can't see them. They have to have their own version of that variable. So that concludes what we looked at today. We looked at how parameters how arguments and parameters are passed to each other inside of functions. Thank you very much.